Okay, I think we are live. So hi everyone, and today the purpose of today's class is to discuss about the various variants of next greater element. I understand it's a very I am pretty sure that you know about this, that it's a pretty common interview question, and there are many problems that you can solve using next greater element, like the variants of next greater element. And today we'll be discussing all about next greater element, not only next greater element but the other variants, like what is the previous lesser element, previous greater element, next lesser element, and all these variants, right? So we'll wait for some time for others to join in, and meanwhile, if you can quickly let me know if you guys can hear me, or I can check that on my end as well. Okay, I think you can hear me. So okay, so I think you guys can hear me. Meanwhile, you can, if you don't know about next greater element, definitely try to read the problem statement. I'll definitely discuss it, but yeah, just try to read the problem statement yourself once, and we'll wait if anyone else wants to join in, and after that, we'll start discussing the problem. Okay, so just read the problem statement meanwhile, and after that, we'll start. Hey Dilip, thanks for letting me know. Okay. Uh, okay. Let's start. People will join in as we go. So the question that we will be solving, although we'll not be sticking to this question, there are many other things. There are many other variants of this that will go through. By variants, I mean the various, like, we are here. We are specifically finding the next greater element, but there can be next lesser element, previous greater element, previous lesser element. So how can you easily find everything? We'll just discuss about that, or how you can modify next greater element to find all those things. We'll discuss about that, and that's the agenda for this class, right? So given an array of size n, and each of them are distinct elements, that is a good thing that's given to you, that each of them will be distinct elements. Although it's not a necessity to have distinct elements, you can have similar elements as well, but it is given that we have distinct elements, so that's fine. The task is to find the next greater element for each of the element of the array in order of their appearance in the array. So what is next greater element? Next greater element often is of an element in the array. The next greater element of any element of the array is the nearest element on the right hand side, which is greater than the current element. So for any element of the array, the next greater element will be the nearest element on the right hand side that is greater than the current element that we are considering, like for which we are finding the next greater element. So as the name suggests, it is the next greater element. Next means what? Towards the right, right? So towards the right, what is the first greater element than the current element is the next greater element for the current element. So that is the definition of next greater element. And if there does not exist a next greater element for a given element, the next greater element will be regarded as -1. So we'll keep the next greater element as -1, right? So that's the definition of next greater element. So let's quickly look into examples for this. One second. Okay, so we'll look into examples. So we are given an array here, 1 3 2 4, 1 3 2 4, right? This is the array that is given to us. So 1 3 2 4 is the array that is given to us. 1 3 2 4. Okay, we'll find the next greater element for each of the elements. For 1, what is the nearest element to 1 on the right hand side such that it is greater than 1? So for 1, the nearest element on the right hand side is 3 and it is greater than 1. So for 1, the NG will be 3. For 3, what is the nearest element on the right hand side that is greater than 3? So is 2 greater than 3? No, right? 4 is greater than 3. So 4 is the nearest element on the right hand side that is greater than 3. For 2, the nearest element on the right hand side that is greater than 2, it is 4, right? So 4, and for 4 there is no element on the right hand side, so it will be -1. So this is the next greater element array for the given array. So if you see, the answer is 3, 4, 4, -1, which is what we have found. Okay, so we'll look into another example. Just let me see. Okay, let me know if you have any doubts. Please feel free to write in the chat if you have any doubts. And this is a very important interview question. Like, there are many variations or many questions that you can actually solve using this technique, right? And in fact, day after tomorrow we'll be solving such a question, that is the largest area of the histogram. So if you want, after this you can actually go try that question. It's a hard problem, so definitely give it a try, and it's a very popular interview question. Largest area in a histogram, right? So just give it a try. So here we have 68013. So what about 68013? So 68013, so let's write it down here. 68013. Okay, for 6, what is the nearest element on the right hand side of 6 that is greater than 6? It is 8, right? So 8 is the next greater element for 6. For 8, what is the nearest element on the right hand side of 8 that is greater than 8? So if you see on the right hand side of 8, there is no element that is greater than 8, right? So it will be -1. For 0, what is the nearest element on the right hand side that is greater than 0? It is 1. So you will write 1 here. For 1, it will be 3. And for 3, it will be again -1. There is no element on the right hand side. So this is what the next greater element is, right? So I hope that this is clear with everyone. What is the meaning of next greater element? So you can actually try finding the next greater. Okay, there is no other example. So yeah, anyways, that's fine. Okay, so we'll take an example ourselves. We'll create an example ourselves, and what you can do is you can let me know what will be the next greater element for this array, right? So let's create an array here, A. The array will be 2, 1, 3. We have only distinct elements, right? Okay, so it will be 7, 4, 7, 4, 8, 5, 6, 5, 1, 6, 5, 8, 6, 5, 9, 8, 6, 5, 9. Okay, I think every element is distinct element here. Can you tell me what is the next greater element array for this array? Can anyone tell me what will be the next greater element for this array? Just write it in the chat. What will be the next greater element for this array? Let's go one by one. What will be the next greater element for 2? What will be the next greater element for 2? What will be the next greater element for 2? What is the name of this lecture series? So the name of this lecture series is basically we are solving Amazon interview questions. Okay, 3. Yes. The next greater element of 2 is the nearest element on the right hand side of 2 that is greater than 2. So if you see, the nearest element on the right hand side of 2 which is greater than 2 is 3. So 3 will be the next greater element. For 2 it will be 3, for 3 it's 7. Good. So for 1 it will be 3 again. For 3 it will be 7. For 7 it will be 8, right? For 7 it will be 8. For 4 it will be 8. For 8 it will be 9. For 6 it will be 9. For 5 it will be 9. For 9 it will be -1. So this will be the next greater element array. Everyone agrees on this with me? By the way, look, the series is basically I'm just solving a few questions from Amazon interviews. So it's called Amazon interviews, I think, something like that. You can look into the playlist name. Yes. So I think everyone agrees on this with me. Like this will be the next greater element. So how do we find this, right? Now that's the question. How do we find this? So to find this, we'll use stacks, right? We'll use a stack, but there is a property that this stack will follow. So we'll use a stack to determine the next greater element array. So this is the stack that we'll use. So let's create the next greater element array here. Okay. Now we'll use the stack, right? What we will do is we will whenever okay, what does the stack contain? First thing is, what does the stack contain? The stack will contain only those elements whose next greater element is not found yet. So it will contain only those elements whose next greater element is not found yet. The stack will contain only those elements whose next greater element we haven't found yet, and we will move from left to right. Our movement in the array will be from left to right, this direction, right? So left to right we will move in the array and we'll push them into the stack. And what will be there in the stack? At any point of time, the stack will only contain the elements whose next greater element we haven't found yet, right? And the elements, obviously the elements that we have visited means we are going from left to right. It doesn't means when we are at here all the elements will be there in the stack, right? It will only contain the elements that we have visited while moving from left to right and whose next greater element we haven't found yet. Okay, now with this claim that it will contain only those elements whose next greater element is not found yet, we have a very important property on this stack. The property being, the stack will be what? The stack will be a decreasing stack. The stack will be a decreasing stack. That is, from bottom to top, the stack will be decreasing, right? It will be decreasing. Let's understand why that's the case. Let's say I have some element here in the stack. Let's call it A. Element A in the stack, right? I have an element A in the stack. On top of it, there is a element B. I am saying the stack should be increasing, right? Let's try to counter this, right? Let's try to counter that the stack is not decreasing, but it only contains those elements that are visited and whose next greater element is not found yet, but it is not decreasing. That's what we counter, right? If it is not decreasing from bottom to top, that means B will assume that B is greater than A. Then only it is not decreasing, right? B is greater than A, then it is not decreasing. If that is the case, that B is greater than A, who is coming on top of whom? B is coming on top of A. What does this mean? B is coming on top of A. What does this mean? B is coming on top of A. It means that, just see, how do we push into the stack? We push like this, right? We push like this, we remove on the same direction. So B is coming on top of A. It means B was pushed after A was pushed. We are pushing B after we have pushed A. That's why B is coming on top of A, right? We are pushing B. Just think about this. Why B is coming on top of A? It is because A has been stacked before B. So A has been pushed into the stack before B. Now, what is the order in which we are moving in the array? The order in which we are moving in the array is left to right. We have already discussed that. We are moving from left to right. This direction we are moving. Now, definitely B comes after A. As B is pushed after A, B will come after A because it's pushed after A, right? So, in the array, there is somewhere A, and after that, there is somewhere B, right? And we are saying that we haven't found the next greater element of A, because that's the claim for this stack, right? That's what we are containing in the stack. Only the elements whose next greater element is not found yet. So we are telling that we haven't found the next greater element for A yet, although there is an element on the right hand side of A, which is B, which is greater than A. Does both the things go with each other? We are telling that A's next greater element has not been found yet, but we are also telling that we have found the element B which is greater than A and is on the right side of A. So that is the next greater element of A, right? So A should not be there in the stack. So definitely this is not a valid stack that we are talking about. So this means that the stack should be decreasing, right? The stack that we have should be decreasing. Let's rub everything here. So the stack that we have here, it should be decreasing. It should be decreasing stack, right? And if we just maintain this property, we actually will be creating the next greater element array. We will be actually able to successfully create the next greater element array. Also, one more thing, what do we do is when we insert elements, right? Okay, let's actually dry run and we'll understand better. Okay, so let's try for this array that we have considered here, 213748675. 213748675. Okay, let's consider for this. So first of all, what we are doing here, we have two, right? And the stack is empty, so we will just push 2 into the stack. So we are just pushing 2 into the stack, and this is the next data element that will create, and then we will see that if it is correct or not. Okay, 2 we are pushing into the stack. After that we have 1, right? When we are pushing 1 into the stack, we see that is the topmost element that is there in the stack smaller than 1. So the topmost element on the stack is not empty, so we can check the topmost element. This topmost element is 2, which is not greater than 1, so we will just push 1 into the stack. So 1 just gets pushed into the stack. Okay, now we come to 3. Now the topmost element of the stack, is 3 greater than the topmost element? 3 is greater than the topmost element, right? 3 is greater than the topmost element, that is 1. So we will make the next greater element for 1 to be 3. So the next greater element for 1 will be 3 here, right? And we will remove 1 from the stack. After that, what is there at the top of the stack? We'll continue this as long as the topmost element is greater than the current element, or the stack is empty, right? Now the current element is 2. Is 3 greater than 2? Yes, 3 is greater than 2. So we'll make the next greater element for 2 to be 3, and we will remove 2 from the stack as well. We have found its next greater element. So the stack will only contain elements whose next greater element is not found yet. Now it's time for us to push 3 into the stack. So 3 is pushed into the stack. Okay, after this we have what? We are pushing 3 to the stack. After that we are coming to 7. We have 7. Is 7 greater than the top of the stack, that is 3? Yes, it is. So the next greater element for 3 will be 7, and we will remove 3 from the stack. Now the stack is empty, so we'll just push 7 into the stack. So just 7 is pushed into the stack. After that we have 4. Is 4 greater than the top element of the stack? Top element of the stack is 7. 4 is not greater than 7. So we will push 4 into the stack. We will just push 4 into the stack. And see that stack is decreasing from bottom to top. After that we have 8. We'll start with the topmost element. Is 8 greater than 4? Yes, it is. So next greater element for 4 will be 8. So next greater element for 4 will be 8. So we'll write 8 here. Now what is the top of the stack? The top of the stack is 7. Is 8 greater than 7? Yes, it is greater than 7. So 7 is also removed from the stack. We mark the next greater element of 7 to be 8. Now the stack is empty, so we push 8 into the stack. Right. After that we have 6. So 6, top of the stack is 8. So we have 6. So 6 will just be pushed into the stack. So we'll just push 6 into the stack. After that we have 5. Again we'll just push 5 into the stack. After that we have 9. Now see, the stack is decreasing as well. So for 9, first of all we'll compare with 5. Is 9 greater than 5? Yes. So the next greater element for 5 will be 9. So let's write it down here. Okay. Is 6 greater than 9? Now the top of the stack is 6. Is 6 greater than 9? Yes, 6 is greater than 9. So the next data element for 6 will also be 9. And 8, is 8 greater than 9? Yes, 8 is 9 greater than 8? Yes, 9 is greater than 8. So the next data element for 8 will be 9 again. Now 9 is pushed into the stack because the stack is empty. Now we have ended the loop. So the only element remaining in the stack, whatever element remains in the stack, all their next data elements will be -1. So 9 is remaining. So the next data element for 9 will be -1. And if you see, this is the exact next data element that we created earlier, right? So this is the next data element that we have formed. So this is how we'll create the next data element array. Now coming to the complexity, right? Just first of all, let's just discuss a pseudocode. What will it look like? So we'll have something like this for I equals to 0 to n. We'll loop from left to right. Now we will check while not stack.empty. Stack is not empty. And then stack.top, whatever is the top of the stack, that is less than a of the current element that we have, a of I. If that's the case, then we'll update the next iter element, update next iter element for stack.top to a of I. We'll update the next iter element for stack.top to a of I, and we'll do stack.pop. We'll remove that from the stack.pop. And finally, we'll push into the stack. So stack.push a of I, right? Okay. Now, if you see, there are two loops. Can anyone tell what is the complexity of this? What is the time complexity of this code that I've written here? What is the time complexity? Can anyone tell? What is the time complexity of this code? What is the time complexity of this code that I've written here? I have two loops. If you see carefully, I have two loops. I equals to 0, I less than n, and inside this I have another stack loop. So what will be the time complexity? Can anyone tell? What is the time complexity? N squared. Okay. Look. Okay. So it's a very common thing that you will see that whenever there are two loops, you will definitely think that it is n squared, which is very much acceptable, right? Because generally when we have two nested loops, it anyways goes up to n squared. But if you look into this carefully, just think about this loop. What exactly happens? You are removing elements in this loop. So if you actually think about this properly, every element is just inserted once, and every element gets removed at max once, right? When an element is removed, you are not reinserting the elements as well, right? And also you are removing element that also is supporting, because see, the stack is decreasing, right? So let's say you have 5 elements that are less than a of I. You have a of I, but it is decreasing, so it is increasing from the top, right? So you can actually remove elements from the top. A few elements from the top will always get removed. That's basically why it is decreasing, right? That's basically because it is decreasing. A few elements on the top will get removed. So this code actually works. So you never actually reinsert element. If you see inside this loop, do we have any code for reinserting the elements? No, right? So each element is inserted only once and it is removed only once. So for all the iterations, every element is inserted only once and removed only once. So this loop is becoming independent of this outer loop. So the total complexity becomes order of n. The outer loop is running for order of n, and the inner loop, for all possible values of the outer loop, it will run total of order of n. because each element is just removed once and inserted once, right? So that's why it is overall order of n complexity. Does this make sense? Why is it order of n? Yes, I'll be coming live daily. For this month at least, I have lives daily at 6 p.m. We'll solve one problem every day 6 p.m. Other than that, for Saturday and Sunday, I've kept two special streams for resume reviews. So that are there. That will be around, I think, 4 p.m. Let's. I haven't finalized on the time, so let's see. Okay, I think it's clear with everyone why it is order of n. This inside loop is independent of the outer loop. So irrespective of two loops nested inside each other, this loop will only run for order of n time, because each element is inserted once, each element gets removed only once, right? So this will run for order of n time only over all the possible loops, right? So that is why it is order of n overall. So we have a order of n complexity. So let's quickly write the code for this. Okay, 1 second. Accessibility here comes. Okay, so let's quickly write the code for this, and then we'll discuss about the variance, right? So the next data element, now here we'll write the code a bit differently. We'll generally, we do not, in the stack we were pushing the elements itself, right? But generally we just push the indices of the elements, and then we compare the corresponding array value. Whenever you are pushing an index, you can definitely get the corresponding array value as well, right? So while comparing, just use the array value. So we'll create the next large set element, vector long ng ng and n plus 1, right? Sorry, not n plus 1, n. So what we'll do, we'll keep a stack with the indices, and we'll run a loop here. Let's go full screen. Okay, for int I equals to 0, I less than n, I plus plus, the exact pseudocode that I'd written. Only difference will be I'll be pushing the index instead of, like, what I'll do here, I'll push the index here. Basically I'll push I here instead of a of I, right? But again, like, I have the indices in the stack, I can definitely get out their corresponding values, the array values. So while I make I do a conditional check x dot empty, while not x dot empty, and now ARR of x dot top, right? In the stack we have the indices. So ARR of x dot top, it is less than ARR of I. While that's the case, ng, and why do we push the indices? Because we can populate the ng array like this. Ng x dot top, that will give me the corresponding index. Ng of x dot top will be equals to ARR of I and x dot pop. Okay, and finally whatever is remaining in the stack, while this is outside, yes, this is outside, yes, while not x dot empty, whatever is remaining in the stack, that will be -1 basically. So ng of x dot top equals to -1, or we could have initialized here with -1 itself. That would have also worked, right? So -1 and x dot pop, and you can return x here. So return ng here, sorry, you can just return ng here. So this is the code. So let's and you understand, right, why it is order of n? Because this this loop that I'm running here, this is independent of this outer loop, because every element is just popped once, right? And they're pushed also once. So just think about this. Here we are actually, whenever it is true, it is actually popping the elements. Whenever it is becoming false, it is breaking the loop. So every time it is running, it is actually removing an element. So we are removing each element only once. So that's why total over and it will be total order of n complexity. So if we run this, I think it's working. So let's submit this. Yeah, I think it should work. Yep, it has worked. So this is the next data element, right? Now let's come to the variations of this, and how do we actually modify this to have the other variations. Now, what do I mean by variations? Let's say you are given a question. We have learned about next data element. We have already learned about next data element. But if you are given a question, you have to find the next lesser element. You have to find the next lesser element. What is next lesser element? What is the nearest element on the right hand side that is less than the given value? What is the nearest element on the right hand side that is less than the current array value? So let's say we have an array here 4, 2, 5, 6, 1, 3, something like this, right? So what is the next lesser element array for this? So next lesser element array for this will be, for 4, what is the nearest element of 4 on the right hand side? Next means right hand side. Previous means left hand side. Next means right hand side. Okay. So what is the nearest element on right hand side for 4, which is less than 4? So it is 2. So 2 is the next lesser element. For 2, nearest element on the right hand side less than 2, it is 1. So it will be 1. For 5, nearest element on the right hand side less than 5, that is 1 again. For 6, nearest element on right hand side less than 6, that is 1 again. For 1, nearest element on right hand side that is less than 1, there is nothing. For 3, there is nothing again. So this is the next lesser element array. So how will you modify the existing thing to support next lesser element? Okay, so here instead of next greater element, we want the next lesser element. So just think about this. We can have a very similar logic, right? But there we maintain the stack to be a decreasing stack, right? From bottom to top it was decreasing. What if we maintain the stack to be the increasing stack? What if we make this stack a increasing stack? That is, it will only contain the values whose next lesser element is not found. And with this, it actually becomes an increasing stack, right? Because again, with the same example, let's say we have a and we have B. And if it is not increasing, we are saying that B is less than A. But B is less than A and B is coming after A as well because it is on the top of A. So it is definitely pushed later on. And we are running the loop on the same direction. We are moving from left to right in the array. Right? Yes, exactly. We are moving from left to right in the array. So B is coming on top of A. So that means B is less than A and is on the right hand side of A as well. So definitely B is the next lesser element for A. If we haven't found the next lesser element of A yet, so it should not be there in the stack. So this means that this condition is invalid. So B should always be greater than A or greater than equal to A, right? So the stack will be an increasing stack. So, and how do we maintain the stack to be increasing stack? We can just do the reverse condition here. So if we just reverse this condition here, ARR x dot top is greater than ARR of I, that would just do the that would just help us, right? That would solve the problem. So let's understand if it actually helps us. So we'll just quickly dry run through this example. Just give me a second. Okay, so we'll quickly dry run through this example. I'll just rub everything off here. So what we are doing essentially is our condition now is like this, that ARR x dot top, we had less than condition here. Here it will be greater than condition. Is greater than ARR of I. Is greater than ARR of I, then ARR of I is the next lesser element for x dot top. Right? This is just the condition. So if we dry run this quickly, just see, like, this is the stack that we have. Initially for 4, we will push 4 into the stack. Now we have 2. 2 is 2 less than 4? Yes, 2 is less than 4. So and that is the condition, right? ARR x dot top is greater than ARR of I. So it is greater than 2. So we'll remove 4 from the stack. We'll mark the next data element for 4 to be 2. Now we'll push 2 into the stack because it is empty. So 2 is pushed into the stack. Now we have 5. What is the condition? ARR x dot top. Here, although it is x dot top, it is not the index. We are not storing the index. But we are just think about this to be x dot top for now. X dot top, right? The top element. Okay. So is the top element greater than 5? Is 2 greater than 5? No, right? So we'll push 5 into the stack. So 5 is pushed into the stack. After that we have 6. So is 5 greater than 6? No, right? So 6 is again pushed into the stack. Now we have 1. Is 6 greater than 1. Yes, 6 is greater than 1. So the next lesser element for 6 will be 1. And 6 is removed from the stack. Similarly, 5 also 1 and 2 also it will be greater than 1. So all of them are removed and the next greater elements are marked to be 1. Then 1 is pushed into the stack. After that, 3 is pushed into the stack and we both have these remaining. So their next lesser elements will be -1. Right. So just changing this condition here. ARR x dot top is greater than ARR of I to less than ARR of I to greater than ARR of I. This actually makes the code next lesser element. So if you have, can you explain the time complexity of first variant again? Definitely. So this is the code for the first variant, right? Again, like it's the same thing. The time complexity will remain the same. So for the first variant, I'm saying that although there is a outer loop, right? This is the outer loop, and inside this there is one more loop that is running. So it is very obvious that you will think that it is n square, right? It is very obvious thing, but it is not n square. Why not n square? Just think about this loop. Whenever this loop is executed, what happens? One element is removed from the stack, right? Whenever this loop is executed, one element is removed from the stack. And when this loop is not executed, it breaks then and there. It will break then and there. So every time this loop is executed, it will remove one element. And we are not inserting the element again. It is just removing the elements. And we are inserting each element only once, right? We are inserting each of the elements only once. So what is the total time complexity for this inside loop across all values, irrespective of this outer loop? This will just remove one element, right? Every time it is executed, it will remove one element, and there are n possible elements with us. So overall time complexity, like for all values of I, the entire time complexity will be order of n, because all the elements will be removed at max once. We are not reinserting inside this loop. So this loop complexity will be order of n across all values of I. Does this make sense? Why it is order of n across all values of I? And why is the total complexity order of n? Because this is becoming independent. It doesn't depend on I anymore, because every element is removed at max once. So it is order of n irrespective of I, and I is also order of n. So it is order of n plus n, not n into n. So that's why it is order of n overall, this entire thing, right? So you have to be very careful in these loops, right? Like you have to check how many times it is executing for each iteration. If it is executing for n times each iteration, only then it is n squared. Otherwise it might be very different, right? So that's how you actually compute. So you see that it is irrespective of the outer loop. We know that this will execute at max n times, because every time it is executed, one element is removed from the stack, and we are not reinserting elements within this loop. So every element is just inserted once into the stack and it is removed here. So total n times it will run, irrespective of how many times the outer loop is running, right? So that's basically the time complexity. And to make this the next lesser element, you can just reverse this condition. Is this clear with everyone? How can you find the next lesser element quickly as well? Or do you have any doubts with next lesser element? Just reversing the sign will do the job. Does this make sense with everyone? Let me know in the chat if it is clear with everyone. Just reversing the sign will actually solve. And after that, I have a good question for you. Let me know quickly. Is this clear with you? Why reversing the sign will just find the next lesser element? Okay. Great. So yes, time complexity is order of n plus n, which is order of 2n, which is order of n, right? So that's why it is order of n. Exactly, it is independent loop, so order of n plus n. Okay, so this is next greater element, because if you see what is the condition that you have here, you are removing elements when you are finding a next greater element. Now you are removing elements when you are finding the next lesser element, right? When you are finding the next lesser element, you are removing that element. So this is next lesser element. If this is clear, can you tell how will you find the previous lesser element, previous greater element and previous lesser element? What do I mean by previous greater element, previous lesser element? What is next? What was next greater? Element on the right hand side, nearest element on the right hand side greater than the current element. What is next lesser? Nearest element on the right hand side less than the current element. What is previous greater? Previous greater will be, which is called PGE. Previous greater will be nearest element on the left hand side. Previous, right? Left hand side. Next means right hand side. Previous means left hand side. Nearest element on the left hand side greater than the current element. And previous lesser element, nearest element on the left hand side that is less than the current element, right? So for this, for 4 there is no element on the right hand side. For 2, nearest element on the left hand side greater, so 4 is greater, so it will be 4. For 5, nearest element on the right hand side greater, left hand side greater, so there is no element on left hand side greater than this, so -1 again. 6, -1 again. 1, nearest element on left hand side greater than 6, that will be 6. Greater than 1, that will be 6, and for 3 also it will be 6, so that means previous greater element. Previous lesser element, for 4 it will be -1. For 2, no element on the left hand side, we have only 4, so 4 is not less than 2, so no element on the left hand side is less than 2, so -1. For 5 it will be 2. For 6 it will be 5. For 1 it will be -1. For 3 it will be 1. So this is previous lesser element, right? How do you compute these things quickly? From whatever we have discussed till now, how do you compute these things quickly? Can you tell? How can you compute these things quickly? ARR I minus 1 is greater than S dot top. What do you mean by ARR I minus 1? Can anyone tell how can you quickly find these two? How can you quickly find these two? Can you actually somehow map this to some problem, some of the variant that we have already discussed? Can you somehow map this to some variant that we have already discussed? We have already discussed next greater element. We have already discussed next lesser element. Can we map this to any of these? Can we map these to any of this? Can anyone tell? Flow code. This is the code. Okay, let me explain, right? Let me explain. Previous greater element. What is the previous element, nearest element on the left hand side greater than this? Isn't previous greater element same as next greater element on reverse array? Isn't previous greater element same as next greater element on reverse array? So what is next data element? Nearest element on the right greater than current element. If you just reverse the array, your left becomes your right. So on the reverse array, if you are finding previous greater element, next greater element, that will become in the actual array, that is your previous lesser element, previous greater element. Similarly, previous lesser element will be same as the next lesser element on reverse array. Just think about this. Let's actually take an example. We'll take this example. So this is the array, right? 4 2, and this is the previous greater element. Let's actually take this example here. So we'll reverse this array, right? So the array is now reversed array is 3 1 6 5 2 4. Let's find the next greater element. So next greater element for 3 will be 6. Next greater element for 1 will be 6. Next greater element for 6 will be -1. For 5 it will be -1. For 2 it will be 4. For 4 it will be -1. Now just reverse this, because you have found the next greater element of the reverse array. Now you have to reverse to make it the previous lesser. So if you reverse this array, what does this become? It will become -1 4 -1 -1 6 6. Isn't this thing equals to this thing? Aren't both these things same? Aren't both these things same, right? Both these things are same, right? This is equals to this. So next previous greater element is same as the next greater element of the reverse array. Similarly, previous lesser element is same as the next lesser element of the reverse array, right? So what do? Basically, we don't reverse the array. Instead of that, to find the next previous greater element. So this is the code for next lesser. This is the code for next greater. To find the previous greater, we will just run the loop in a reverse order. Just run this loop in a reverse order, right? This will give you the previous greater. This will give you the previous greater. Now you are just running the loop in a reverse order, and you are just doing the comparison. So it's basically you are processing on the reverse array, right? So next greater element on the reverse array. Similarly, previous lesser, you will just convert this code into next lesser element and run the loop in a reverse order. That will be previous lesser element if you want the previous lesser element, right? Does this make sense with everyone? Like, how have I done this? So just changing the loop and changing this condition, you can have all the 4 things: next greater element, next lesser element, previous greater element, previous lesser element. So whenever it's next, you have to run the loop from left to right. Whenever it's previous, you have to run the loop from right to left. Whenever it's greater, next greater, you have to have a less than condition here, because you want to remove only when the given coming element is greater than the element in the stack. So you have to have this condition. If it is lesser, you have to have the reverse condition, greater than condition. Is this clear with everyone? How is this working? How are the various variants working? Let me know in the chat if it is clear with everyone. Just tell yes if it is clear. If you need some explanation, let me know. Okay, good. So next part will be next part is I'll give you a homework here. So we'll be discussing day after tomorrow on the there is a problem called largest area under histogram, which is a very it's a hard problem. It's marked tagged as a hard problem, but it's a very popular question. So I want you to, like, after this knowledge, just go ahead and try solving the largest area under histogram problem. Don't look into solutions, try solving it for one day, and day after tomorrow we'll definitely discuss, so you will anyways know the solution by then. So just try to solve this, take this as a homework and try to solve this. And tomorrow we'll be discussing on how to implement LRU cache. So that is also pretty interesting. So make sure you join tomorrow as well, same time. So this month, every day at 6 p.m. we'll be having a session. So make sure you join there, and we'll be solving one problem every day. For next month also, I have many plans. So I'll be letting you know, like, by the end of this month, what will be the plans or how will it look. There will be a lot of things that will be done in the next month. So make sure you join the classes and also follow the community posts as well. Cool. So with that, let's end the lecture here, and thank you guys for joining in, and I'll see you tomorrow, same time.